Power system analysis of 66/11 kV distribution. System of Samakhiyari, Kutch. Abstract: this paper proposed power system analysis of 66/11 kV distribution system of Samakhiyari, Kutch. The system being planned is to be optimal with reference to construction cost, performance, and operating efficiency. For this, better planning tools are required. In general, the main power grid tools are load flow analysis, short circuit analysis or fault calculations, stability analysis, etc. The purpose of an electric power system is to get and provide electricity to consumers with reliability and economy. The greatest threat to the system is that of the short circuit. The objective of this study is to simulate short circuit faults on different buses of a system network and to estimate the state of the system before and after a fault, which includes various bus voltages and current flow on various transmission lines. The following document contains necessary information about performing the two most important analysis on the power system. 1. Load flow analysis. 2. Short circuit analysis. Introduction. Electrotherm, India, Limited has engineering metal melting trade since 1983. In Electrotherm from inception, R&D has been Electrotherm's core competence, with a typical concentrate on developing and adopting technologies to customize client wants and creating it a key driver in our multi-divisional growth story. Electrotherm is the solely Indian company with indigenously developed world category technologies of world scale. Our team, centered with a client-first perspective, believes technology ought to be right-sized, with the process designed to reduce waste. Associate in nursing designated to boost product performance with an embedded attitude of customizing engineering and metallurgic solutions to customers that created Electrotherm grow into one amongst the market leaders within the metal melting industries in India and globally. Electrotherm nowadays could be a multi-divisional ISO 9001:2008 certified international company holding a 2,500,000 kW market share within the metal melting trade globally. Electrotherm could be an analysis-driven company with associate in nursing appreciating plus in intellectual capital its primary supply of our multi-divisional growth story. The corporate has developed robust processes with intrinsical learning and continuous enhancements in each job performed. This develops effective product lifecycle management and is the foundation of our product innovations to confirm our customers attain their prime line growth. Engineering innovations for the worldwide metal melting trade has been potential thanks to our centered 2,607 staff with a progressive producing facilities, and R&D center manufactures a good spectrum of product for the metal melting trade and electrical vehicles and are manufactured in 4 totally different divisions of the corporate. The client focus of every division in manufacturing is in wheel with the R&D to confirm our customers attain their objectives for prime line growth. 2. Overview of the system. In Electrotherm there are 2 units, ISU and IPU, i.e. integrated steel unit and integrated pipe unit. Both the units are connected with the substation which provide them power. Substation consists of bus 1 and bus 2. Both the buses are connected by bus coupler. In case fault occurs in bus 1, then supply can be provided with the help of bus 2 or vice versa. Electrotherm has its own power plant which is known as captive power plant. One is of 30 MW and another one of 15 MW. Both the power plant produces power which is supplied to the substation by transmission line. Here 30 MW CPP is connected to bus 1 and bus 2, whereas 15 MW is connected to bus 2. There is an alternative source of power which we received from GetCo station. Here the switchyard is used to step down the 6 kV to 11 kV with the help of transformer 1 and transformer 2 of rating. The transformer 1 is connected to bus 1 and transformer 2 is connected to bus 2. In present time the 30 MW CPP is in working condition and 15 MW CPP is purposed. Power is generated from 30 MW CPP and supplied to 11 kV bus line with the help of transmission line. Here in the system 2 loads is connected to the substation ISU and IPU. ISU consist of 4 loads. 1 induction furnace 2F, SMS2. 2 induction furnace GH, SMS2. 3 induction furnace E, SMS2. 4 induction furnace. IPU consist of 4 loads. Rolling mill. 1 space iron plant. 2 Yo-bike division. 3 SMS1 and SMS2. If fault occur in 30 MW CPP, there is an alternative source supply from 66 kV switchyard from GetCo S/S. Here the 66 kV line is further stepped down to 11 kV line with the help of different panels and supplied to bus 1 and bus 2. And the supply continue from the substation to their respective unit. Parts of block diagram. 1.30 MW captive power plant, 2.15 MW captive power plant. 3 switchyard 66 kV. 4. Substation. 5. Integrated steel unit. 6. Integrated pipe unit. 3 load flow analysis of the system. Fig.1 block diagram of the system. 1. 30 MW captive power plant. This power plant generates 30 MW. There are 2 loads in electrotherm, which are integrated steel unit and integrated pipe unit. Both the load receives their respective power from 30 MW CPP, which are connected to the substation bus 1 and bus 2. 2. 15 MW captive power plant. This power plant generates 15 MW. There is only one load connected to 15 MW CPP, and this CPP is connected with BUS2. Bus 2 transfers load to integrated steel unit. 3. Switchyard 66/11 kV. 66 kV incoming line is coming from GetCo. There are 2 step-down transformer of 30 MVA. Transformer step down the voltage to 11 kV. Here the 11 kV line is supplied to the bus 1 and bus 2. 4. Substation. 11 kV supply is coming from 66 kV switchyard, which is connected to BUS1 and BUS2, which transfer the power to different loads, i.e. integrated steel unit and integrated pipe unit. 5. Integrated steel unit. In integrated steel unit, the supply is coming from the 11 kV substation, which transmits power to different load, which are 1. Induction furnace 2F, SMS2. 2. Induction furnace GH, SMS2. 3. Induction furnace E, SMS2. 4. Induction furnace. All load capacity is 30 MW. 6. Integrated pipe unit. In integrated pipe unit, the supply is coming from the 11 kV substation, which transmits power to different load, which are 1. Rolling mill. 2. Space iron plant. 3. Yo-bike division. 4. SMS1 and SMS2. All load capacity is 37.5 MW. Load flow analysis is the most significant and essential approach in investigating issues in facility operation and designing. The power flow analysis, also called the load flow analysis, may be a vital and basic tool involving numerical analysis applied to an influence system. The results play a serious role within the day-to-day operation of any system for its control and economic schedule. The analysis is additionally utilized throughout power system operation procedures, designing growth and development of management strategies. The purpose of any load flow analysis is to calculate precise steady-state voltages and voltage angles of all buses within the network, for fixed load, generator real power and voltage conditions. Once this info is thought, the important and reactive power flows into each line and electrical device. Additionally, as generator reactive power output are often analytically determined, a power flow analysis for a system under actual or projected traditional operation conditions, base case, provide the results that represent a benchmark for comparison of changes within the network flows and voltages in abnormal conditions. The principal info obtained from power flow analysis, also known as the load flow study, is that the magnitude and point in time of the voltage at each bus and real and reactive power flowing in every line. 4. Load flow diagram of entire system. V. Load flow result of entire system. After analyze the ME power report of ET power system, power loss 2.61 MVAR, reactive power loss 30 MW total, we find out the 45 MW real power generation, 25.11 load, 22.5 MVAR total MVAR load. The line, which is MVAR reactive power generation 2.83 MW total real, connected with two bus No. 2, and bus No. 16. This line is overloaded because of the 3 generator connected with bus No. 2. Solution of this problem: we can add more one transmission line connected between bus No. 2, and bus No. 16, which will reduce the overload of the transmission line. Otherwise we can change the load on another bus. 6. Short circuit analysis. Short circuit analysis basically consists of determining the steady-state analysis of a linear network with balanced 3-part excitation. Such associate analysis provides currents and voltages during a power grid throughout the faulted condition. This information is required to work out the specified interrupting capability of the circuit breakers and to style correct relaying system. To gather enough data, different types of faults square measure simulated at completely different locations, and also the study is repeated. Ordinarily within the short circuit analysis, all the shunt parameters like masses, line charging admittances are neglected. Then the linear network that has got to be solved includes of transmission network, generator system and fault. By properly combining the representations of these parts we will solve the short drawback. After studied about all fault analysis and their results, we conclude that 3pH line to ground fault is more savior than other faults and its short circuit current is 20.149 ca. Other side single line to ground fault is less savior than to all other faults and its short circuit current is 16.679 ca. 7. Summary of short circuit analysis.